Welcome to section 6.4, Rational Exponents for Algebra 2. And to start our lesson, I have another joke for you. What happened to the plant in math class? The answer? It grew square roots. Let's start off with a quick review of exponential properties. So to start with, we have x to the negative first, which we all know that we have to make our exponents positive, and to do that, I switch its location. So if it's a negative exponent in the numerator, it needs to go in the denominator. If it's negative in the denominator, we need to move that term or that factor to the numerator. The next one, what do you get when you multiply the same bases with different exponents? Hopefully you get x to the m plus n. Third one, how do we simplify x to the m divided by x to the n? Here we subtract our exponents, m minus n. Next one, if I have two factors raised to an exponent, we then want to multiply, or not multiply, but raise each of these factors to that exponent. So this becomes x to the m, y to the m. What if I have a quotient raised to an exponent? Well, we do the same thing. The numerator gets raised to that exponent, as well as all factors in the denominator. And the last one, what if you have a factor that already has an exponent and you're raising it to another power? Well, powers raised to powers, you multiply them. So hopefully you already remember these 6 properties. Okay, now on to the new stuff. So we're going to focus on rational exponents, and our objective is to simplify expressions with rational exponents. And so the two basic forms of rational exponents are a to the 1/nth power and a to the mnth power. Now, we can relate these to radical expressions. If you have a to the 1/nth power, the denominator is actually, in radical form, it is the index. So this is really the nth root of a. And if I have a to the m over n power, again, my denominator is still my index. A is my radicand, but now it's a quantity to the m power. Another way to write this is the nth root of a to the m. So we've already seen the radical forms before. Now we're actually just relating these radical forms to the rational forms. Okay? And we're going to go back and forth both ways. Okay, now let's go ahead and practice this. It says, number 1, rewrite each expression in radical form. So I need to have a radical with my answer. Well, take a look at our first one. We have x to the 1/3 power. Again, your denominator is always going to be your index. So this is really the cube root. Your base is your radicand. And the numerator becomes whatever I raise my radicand to. So this is the cube root of x to the first. Now we don't really need to write x to the first. You can just rewrite it as the cube root of x. Okay, next one for problem number 1. We have x to the 2/5 power. Or, sorry, x to the 2/5 power. So my base is my radicand. The denominator is my index. And this, the numerator, is the exponent on the radicand. So this becomes the 5th root of x squared. And if you wanted to write it as the 5th root of x quantity squared, you can, because these two forms are equivalent. Okay, the last one for problem number 1. We have t to the 3/7 power. Go ahead and try that one on by yourself, and then check your answer against mine. Okay, so hopefully you notice that the denominator is 7. That becomes my index. The numerator is my exponent, and the t, the base, becomes my radicand. So I can either write it as the 7th root of t cubed or the 7th root of t quantity cubed. Example number 2 says rewrite each expression in rational form. So I'm going to take it from radical form and I want to rewrite it in rational form. Now if you remember, radical form looks like this, the nth root of a to the m power, and I want to write that in rational form. So that's going to be whatever my radicand is, that's my base. The exponent that I raise my base to is my numerator, or the numerator of my exponent for rational form, and the index is my denominator. So if I have the nth root of a to the m, that's really a to the m over nth power. Okay, so example 2, rewrite it. You have to look, the square root of 5, that's really an index of 2, and that's 5 to the first power, right? So my base is 5, because that's my radicand, and this is going to become 1/2. The 2 swings around to my denominator, 5 to the 1/2 power. So here, on the second one, I have the 5th root of 15 to the 4th power. Well, my base is 15, and it's 4/5 power, because my index becomes my denominator. Last one, I have the cube root of 4x squared. Now be careful about this, because I have now 2 factors underneath my radical. So this is really 4x squared. I'm going to take all of my radicand, and I'm going to raise it to the 1/3 power. 3 is my denominator, because that's my index in radical form. And at something like this now, when I have more than one factor, I'm going to raise each factor to the 1/3 power. So this is 4 to the 1/3 times x squared to the 1/3. And what happens when you multiply, or when you raise a power to a power? Well, hopefully you said we multiply them. So this is really 4 to the 1/3 times x to the 2/3, because 2 times 1/3 is 2/3. Okay, problem number 3. Okay, problem number 3. It says find the product or quotient using rational exponents. Simplify if possible. So if I'm going to use rational exponents, I do not want radicals. So we need to get rid of them. And remember, your index is your denominator for rational form. Okay, so if I have the cube, or the square root of 3, this is really 3 to the 1/2, because it's 3 to the first and an index of 2, 1/2. And that's going to be multiplied by the 4th root of 3. Well, that's 3, your base, the radicand is your base. It's 3 to the first, so it's going to be to the 1/4. I can now multiply them, whereas in the original form I could not multiply them because they were not like radicals. They did not have the same index. But now in rational form I can multiply them, because if something has the same base and I'm multiplying them together, all I have to do is add their exponents. So I just need to add 1/2 plus 1/4. So that'll be 3 to the 3/4. Okay? Now on the next one, we're going to take each numerator, switch it to rational form, take the denominator, switch it to rational form, and then we're going to look to see if we can simplify. So if I have the square root of x cubed, well, that's really x to the 3/2 power. Okay? And that's going to be over the cube root of x squared. I want to actually rewrite that as x to the 2/3 power. Alright, now going back to the original form, we could not simplify because, again, they did not have the same index. But if I rewrite them in rational form, I can now simplify them. And what is that property that says if I have same basis and I'm dividing them, I have different exponents, how do we simplify them? Well, hopefully you remembered Or you said, well, we subtract their exponents. So that's what I'm going to do here. This is really x, and then what is 3/2 minus 2/3? And for that one, I'm going to need common denominators, which would both be 6. 3/2 would be 9/6. 2/3 in terms of 6 would be 4/6. So 9/6 minus 4/6 is x to the 5/6 power. And that's my answer. Okay, last problem, number 4. We want to simplify each of these. So if they're going to give it to me in rational form, in order for me to simplify that, I'm going to try to convert it to radical form. Alright, so I have on the first problem 25 to the 3/2 power. Well, converting that back to radical form, the denominator is 2, okay? So you want to think, well, that's really the square root of 25, right? And I could think of that as the square root of 25 cubed, or maybe I just want to think of it as the square root of 25 quantity cubed. And I'm going to think of it as the second way more so than this way. And the reason is I can do the square root of 25 and then cube that versus trying to do it this way in my head. I don't know what the 25th to the 3rd power is. Okay, so here on the second way, I want to go ahead and do the square root of 25, which we know is 5, and then I'm going to cube that. And hopefully you know that 5 cubed is 125. And that's going to be our final answer. Eventually, what I would like you to do, if you have a problem like number 4, is to think about the square root of 25 in your head without writing it in radical form and get to something like this. Or, let me back up, get to something like this and then write the final answer. Okay, the next problem. We have x to the 2/3 raised to the negative 6. Well, for this one, I'm not going to convert it back to radical form. I have exponents raised to exponents, and so I'm thinking I want to multiply them together. So it's really x to the 2/3 times negative 6 over 1. Well, 2/3 times negative 6 is x. 2 times negative 6 is negative 12 over 3, which is x to the negative 4th. Now, I would want you to simplify that so I do not have a negative exponent. And if you remember your exponential rules, I need to take this factor. If it's negative, if my exponent is negative in the numerator, I need to move it to the denominator. So this becomes 1 over x to the 4th. Okay, and the last problem. I have negative 32 y to the 15th, all raised to the 1/5 power. So what I'm going to do, I have 2 factors in this quantity. I'm going to raise each of those factors to the 1/5 power. But on the y's, you'll notice that you have y to the 15th, and again, I'm raising it to the 1/5 power. So for the y's, I'm going to end up multiplying those powers together. Because powers raised to powers means we multiply them. I'm going to choose a different marker. So this becomes 15 times 1/5 is y cubed. Okay, for negative 32 to the 1/5. Again, my denominator is 5. So I'm really thinking, what is the 5th root of negative 32? Or in other words, what times itself 5 times gives me negative 32? Hopefully you got to realize that's going to be a small number. Well, the 5th root of negative 32 is really negative 2. And so this is going to be negative 2 to the 1st because I still have that numerator. Well, negative 2 to the 1st is just negative 2. So my final answer is going to be negative 2 y cubed. Now I know this section is tough, so please come find me tomorrow if you have any questions.